root mod of z. So mod of z again replace with 25 minus x, that is 7. So 7 divided by 2 as it is, bracket over. Now we simplify our term. So plus or minus under root of 25 plus 7, that is nothing but 32 divided by 2, that is as it is, plus I as it is under root of 25 minus 7, that is 18 divided by 2 as it is, bracket complete. Now again we simplify under root of 32 divided by 2, so this is nothing but 16, so under root of 16, and here under root of 18 divided by 2, that is 9. Now under root of 16, that is nothing but 4, plus under root of 9, that is 3. So this is our answer. Here just replace I here as it is 3i. So our complex number, that is z is equal to 7 plus 24i under root, that is square root, our answer, that is plus or minus 4 plus 3i. So this is our answer. Now we move to our next question. Our next question, that is 5 plus 12i. So same way our z value, that is 5 plus 12i. We want to find out under root of z, square root of z, that is question mark. Again write down the equation. So under root of z is equal to plus or minus under root of mod z plus x divided by 2. Here our y value, that is positive, this is our x value, this is our y value, our y value, that is positive. So equation, that is here plus I under root of mod of z minus x divided by 2. So first of all we want to find out mod of z. So mod of z is equal to under root of x square plus y square. Our x value, that is 5, our y value, that is 12. So under root of 5 square plus here y value, that is 12, so 12 square is equal to 5 square, that is 25 plus 12 square, that is 144. Now addition of the under root of 25 plus 144, that is 139, and square root of 139, that is 13. So we replace 13 value to our main equation, that is mod of z. So write our main equation, that is under root of z is equal to plus or minus under root as it is mod of z, that is 13 plus sign as it is, x value, that is 5 divide by 2 as it is, plus sign I under root as it is, mod of z, that is 13, minus sign as it is, x value, that is 5, divide by 2 as it is. Now we simplify our term, is equal to plus or minus under root 13 plus 5, that is 18, divide by 2 as it is here, plus I under root of 13 minus 5, that is 8, divide by 2 as it is. Now we simplify our term, here 9, 18 divide by 2, that is 9, here 8 divide by 2, that is 4. So finally we can write plus or minus under root of 9, that is 3, plus sign as it is, I as it is, under root of 4, that is 2. So our final answer, that is plus or minus 3 plus I2, and our main complex number question, that is z is equal to 5 plus 12i. Now we move to our next question. Next question, that is 21 minus 20i. So we write down our question, fourth one, z value, that is 21 minus 20i. So we write down find value, that is under root of z, that is question mark, and equation of the square root of z, that is plus or minus under root of mod of z plus x divide by 2, and here our y value, that is negative, so write here negative minus sign I under root of same mod of z minus x divide by 2. Now for square root equation we want to find out mod of z. So mod of z is equal to, again write same, x square plus y square, here 21, that is x, here 20, that is y. So replace here under root of x square, that is nothing but 21 square, plus sign as it is, y square, that is minus 20 square. Now simplify 21 square, that is 441, plus minus 20 square, so negative square, that becomes positive, and 20 square, that is 400. Now we simplify our term, under root of 441 plus 400, that becomes 841, and under root of 841, that is 29. Now we replace mod of z value, that is 29, to our main equation, that is square root of z. So under root of z is equal to plus or minus under root of mod z, that is 29, plus sign as it is, x value, that is 21, divide by 2 as it is, minus I under root of mod of z, that is 29, minus x value, that is 21, divided by 2 as it is. Now we simplify our term, that is plus or minus under root of as it is 29 plus 21, so answer that is 50, divided by 2 as it is minus I under root 29 minus 21, so answer that is 8, divided by 2 as it is. Now we simplify our term, that is 50 divided by 2, that is 25, and 8 divided by 2, that is 4. So we can write our final answer, that is plus or minus under root of 25 only, that becomes 5, minus sign as it is, I as it is, under root of 4, that is 2. So our final answer, that is square root of 21 minus 20i, that is plus or minus 5 minus I 2. Now we move to our next question, that is if z is equal to 1 plus or minus I, then prove z square minus 2z plus 2 is equal to 0. So here we just replace z is equal to 1 plus I first of all for our equation, and then replace 1 minus I to our this equation. So we write down our main equation, that is z square minus 2z plus 2, and we want to prove this equation is equal to 0 when z is equal to 1 plus I, and second case z is equal to 1 minus I. So replace first of all when z is equal to 1 plus I, so our this equation becomes 1 plus I square z square, so 1 plus I square, minus sign as it is, 2 as it is, z value that is 1 plus I, plus sign as it is, and 2 here as it is. Now we want to simplify this equation, 1 plus I square, that is a plus b square, so simplification, that is first term square plus 2 into first term into second term plus second term square, so 1 square, that is 1 plus 2 into first term, that is 1 into second term, that is I, and then plus last term, that means second term square, that is I square, minus 2 into 1, that is minus 2, minus 2 into plus I, that is minus 2i, plus 2 as it is. Now again we want to simplify over this term, here 1 as it is, plus 2 into 1 into I, that is 2i, plus I square, that is minus 1, so replace here minus 1, minus 2 as it is, minus 2i as it is, plus 2 as it is. Now just summation and addition of our this step, here minus 2 and here plus 2 cancel out, here plus 2i and minus 2i cancel out, here plus 1 and minus 1 cancel out, so is equal to 0, no any value, that means 0. So in this way, when z is equal to 1 plus I, we prove z square minus 2z plus 2 is equal to 0 when z is equal to 1 plus I. Now second case, that is 1 minus I. So we replace z is equal to 1 minus I here. So our main equation, that is z square minus 2z plus 2. Now we want to prove when z is equal to 1 minus I. So replace again here 1 minus I to this equation. So 1 minus I square minus sign as it is minus 2, z, that is 1 minus I plus as it is, and then 2. Now again we want to simplify this equation. 1 minus I square, that is first term square, that is 1, minus 2 into first term into last term, that is I, and then last term square, so plus last term, that is I square. Now we simplify minus 2 into 1, that is minus 2, minus 2 into minus I, that is plus 2I, in remaining term, that is plus 2. Now again we simplify our this step, is equal to 1 minus 2 into 1 into I, that is 2I, plus I square here minus 1, so here minus 1, minus 2 as it is, plus 2I as it is, plus 2 as it is. Now we simplify our this step, here minus 2 and here plus 2, both are cancel out, here minus 2I and plus 2I, both are cancel out, here 1 and here minus 1 again cancel out, so nothing but 0.